So, you think you've mastered the product rule? Well, let's test your understanding with a difficult integration question. So, first thing we do is we set up u and v and the derivatives. Now we have to know whether we use the exponential or sine x as u. And to do that, we must use the late rule. So the late rule gives us an order of priority, and obviously the group with higher priority is the group we make u. The late group tells us which function we must use as u, because that group has priority. Late is built upon L for natural logarithm, ln, A for algebraic function, T for trig, and E for exponential. So, using the late method, we see that trig has a higher priority over exponential, therefore u equals sine x. And then the other function, being the exponential, is use the derivative of v. The derivative of sine x is cos x, therefore the derivative of u is cos x. The derivative of v is e to the power of x, so we must integrate e to the x to find v, right? Because v dash is the derivative. So integrating e to the x, we know that gives us e to the x. Now we apply the product rule, which is given to you in your formula booklet. So we do uv, so ex sine x, minus the integral of u dash and v, so minus ex cos x. So now we've set up the expression, we must now use the product rule again on ex cos x. And again we must use the late rule. Now we apply the same thing, the derivative of u is minus sine x, and the integral of e to the x is e to the x. So now we apply the product rule. So again, uv minus the integral of u dash and v, which puts it in this form. But as you can see, there's a negative inside the integral, but you can always take that out, which then leaves it in this form. But then you notice we get the integral of ex sine x again, which is what we were trying to originally solve. So now you must think, what do we do from here? Well, this is called a cyclic integral. So what we do now is equate the original expression, so what we were trying to solve, with what we've just got here, because it is the same thing. Remember, the integral of ex sine x dx equals to ex sine x minus ex cos x minus the integral of ex sine x dx, right? That's why it's called a cyclic integral. It comes back. So if I rewrite the expression, it may make it more clear. So now we collect like terms. So we bring this integral to this side, which gives us this. And originally, we wanted to find the integral of ex sine x dx. So what do we do from here? We divide it by 2, which gives it to us in this form, which is basically your answer. But you can't miss the most important part of an indefinite integral, the constant. So if you want to clean it up a bit and make it look a little bit nicer, it'll be put in this form.